Prime numbers. They sound like something a superhero might seek out, but in the world of mathematics, they are the superheroes. These numbers, divisible only by 1 in themselves, hold the keys to unlocking many mathematical mysteries. They are the atoms of the numerical universe, the fundamental building blocks from which all other whole numbers are constructed. Understanding prime numbers is like understanding the very DNA of mathematics. Imagine a child with a set of building blocks. With just a few basic shapes, they can create an endless array of structures. Prime numbers are like those basic building blocks, simple, yet powerful. They hold a unique and fundamental place in the world of numbers. Their seemingly simple definition belies a depth and complexity that has fascinated mathematicians for centuries. The journey into the world of prime numbers is an adventure. It's a journey filled with wonder, mystery, and the thrill of the unknown. These enigmatic numbers, scattered seemingly randomly across the number line, hold the potential to unlock secrets that we are only just beginning to grasp. Join us as we delve into the fascinating world of prime numbers and explore the secrets they hold. One of the most important concepts in mathematics is the idea that every whole number can be broken down into its prime factors. This is like taking a complex Lego structure and reducing it back to its individual bricks. This concept is so fundamental that it's called the Fundamental Theorem of Arithmetic. It states that any whole number greater than 1 can be expressed uniquely as a product of prime numbers. Let's take the number 12 as an example. We can break it down into 2 times 6, but 6 itself can be further broken down into 2 times 3. So the prime factorization of 12 is 2 times 2 times 3, or 2 squared times 3. No matter how large the number, we can always reduce it down to its prime factors. This makes prime numbers the building blocks of all other whole numbers. This unique property of prime numbers has profound implications. It means that understanding prime numbers is crucial to understanding the structure of all whole numbers. They are the atoms of the mathematical world, the indivisible units from which everything else is built. Their importance in mathematics cannot be overstated. The Fundamental Theorem of Arithmetic is a cornerstone of number theory, the branch of mathematics that studies the properties of integers. It provides a framework for understanding the relationships between numbers and has important applications in cryptography, computer science, and other fields. Prime numbers might seem like random occurrences on the number line, but there are hidden patterns waiting to be discovered. One way to visualize these patterns is through the Ulam spiral. Named after mathematician Stanislaw Ulam, this spiral arranges the natural numbers in a square spiral. The prime numbers within this spiral tend to cluster along diagonal and horizontal lines, revealing unexpected order within the apparent randomness. Another interesting pattern emerges when we look at the gaps between consecutive prime numbers. While these gaps can be arbitrarily large, there seems to be a tendency for them to be small. This observation is known as the twin prime conjecture, which posits that there are infinitely many pairs of prime numbers that differ by only 2, such as 11 and 13 or 29 and 31. These visual representations of prime numbers highlight the beauty and intrigue of these mathematical objects. They show that even in the seemingly chaotic world of numbers, there is underlying order and structure. The patterns we observe in the distribution of prime numbers provide clues about their nature and inspire mathematicians to search for deeper explanations. Despite centuries of study, prime numbers continue to baffle and intrigue mathematicians. Many questions about their distribution and properties remain unanswered, posing some of the most challenging problems in mathematics. These unsolved problems, like siren songs, lure mathematicians with their intellectual allure, promising fame and glory to those who can crack their codes. One such enigma is Goldbach's conjecture, which proposes that every even number greater than 2 can be expressed as the sum of 2 prime numbers. For example, 10 can be written as 3 plus 7, and 24 can be written as 11 plus 13. While this conjecture has been tested and found to hold true for vast numbers, its proof for all even numbers remains elusive. Another tantalizing mystery is the distribution of prime numbers. While we know that there are infinitely many prime numbers, their distribution becomes less dense as we move towards larger numbers. Understanding this distribution is crucial for many applications, including cryptography and coding theory.